All right, well, if we go to the Assignments tab on Blackboard, we have a new program. Program 6 is out. And this introduces the topic of interfaces, which is kind of an interesting feature of the language. And I'll talk a little bit about that after we take a quick look at what's going on in this one. I'll talk in a general way about interfaces. There are two items you will want to grab. The card.java. So this program we're going to do is based on one that I do in Java 1, which is a credit card simulator. And we're going to expand it, but I don't ask you to rewrite the credit card simulator. So we're going to have card.java available to us, so you can download that for our business object. And I really had intended to have you do the setup of this form before we came to class tonight, and I forgot to put that out for you to do, and you're working on the other program anyway. So I actually have a starter project for you. So I've got some code that's already been written. So you'll want to bring the accounts starter down as well. And then go out to your drive and make sure you unzip your accounts starter. So copy, paste it in. And actually, well, let's see, I don't know, we'll probably need to open up accounts. So it comes out as accounts after you unzip it, and it should be just the form, unless I've made a horrible mistake, which is possible. But let's take a quick look at what is going on here, and then I'll talk about interfaces in general. All right. So in the credit card simulator that I do in Java 1, you have an account that you create. So you can either open a new or an existing account, and it's just a credit card. And so you have a default starting credit limit, and of course the balance starts at 0, and it creates an account number for you. And then you make charges and payments. And in fact, there was an interest rate, which was a kind of charge, and then there was a credit limit increase request, which I didn't carry over to this assignment. But you also want to be able to display the history of every transaction that you process against the account. And what we're going to do here is we're going to expand this into a hierarchy, or rather an inheritance tree, with two actually separate branches, if you will, or really separate trunks. One is credit accounts, and one is for asset accounts. So the processes have been moved into menus, which I think I left on the starter I gave you. We'll take a quick look. But if you have a credit account, you can have a regular credit card, which is like what we did in Java 1, or we're now going to add this new thing called an equity line. So an equity line creates the credit limit based on a specific equity value, like a home equity credit line. And so there's a factor that will be used there. And then on a asset account, we're basically going to add checking and savings accounts as alternative types of financial accounts that we might have. Plus, we're going to add a what are we going to add? We're going to add. I'm sorry. I'm really fading fast. We're going to add the money market account. Where is it? Did I put it up here? Asset account, account Java. well, I guess it's explained somewhere. Anyway, it's going to be a money market account, which of course operates like a savings account, but has some limitations, particularly transaction limitations, how often you can access the account in a given time period. So the structure that we're going to impose on this new project is to have two groups of financial operations: an asset account group, which will be your checking, savings, and money market. And those, so a checking and a savings and a money market are subclasses of an asset account. And so that's a normal inheritance that we've become familiar with. And then the credit account side, which has the credit card and the equity line. So those two subclasses will extend our credit account. But what we're adding is this thing that sits on top called an account interface. And so what we're proposing is that all financial objects need to have certain things in common. They need to be able to show their account number and the type of account that it is and the balance on the account. Oh my. The more I talk, the harder it becomes. How much, is there a credit limit if it's a credit account? But some of these things are held in common and some are not. And so when you have two inheritance trees that are very similar but not exactly the same, you have an issue of, well, can I put them all together in some way? Can I have an asset account group work with a credit account group, or are they really separate objects, and what does that mean? And so what Java gives you, which is different than a language like C, is that we can create what's called an interface, which defines methods that will be held in common between the two trees, but they are still considered separate, so that a checking account extends the credit account superclass, but it cannot extend the asset, even if there was something in the asset account that might be useful for a checking or savings account. In Java, you can only extend one superclass. In other words, a subclass can only have one class identified on the extends setting, or the extends line. Oh boy, this may get very bad. But in languages like C, C++, you can actually have an account inherit from two different, you can have a class inherit from two different superclasses. So you can get a whole mishmash. Well, instead of doing that multiple inheritance approach, Java introduces interfaces. And so a subclass can only extend one superclass, but it can implement, and that's going to be our keyword, implement. It can implement multiple interfaces. And so we're actually going to build, in this little example, we're going to build a structure where everything is essentially seen as an account, which is the interface, and that lets us put everything together, as it were. I know that that's sort of nebulous. Maybe I should have put some diagrams on the board, but the folks at home wouldn't see them. So I think it'll be clearer when you start to see how it's going to work. And as we start to put some code to it, I think it will become clear. Anyway, on our form, we've got this line at the top, which allows you to create accounts of different types. So every account subclass is going to have its own two-character type code, and that's going to be how things are managed in terms of the individual accounts. But that line isn't active all the time. It's only active when you're actually trying to create a new account. After that, the information goes in the main body of the form and the transactions occur in the bottom. So let's go ahead and, oops, I don't need that at all. That's previous class. Let's open up our NetBeans and see if we can open, so you don't have to do a new project here, you can do an open project on the accounts zip file that you just downloaded and extracted. So if you did a correct extraction, you should have accounts showing as a Java project in your grouping. Everyone was okay on that step? So let's open that project. And right now, all you have is accounts as the folder, and that has the form in it. Everyone get there? And if you click on source code, there shouldn't be anything behind except the default startup code. So mine is empty. But I do believe if you click on the file menu, all the menus I built for you. Okay. So I'm going to use some source packages that are a little different than I normally use just to help reinforce this separation of entities. So on source packages, let's create a new Java package. I'm so sorry. I may have to step out and get a drink here. A new Java package that I'm going to call Asset Interface. So I'm going to put the interface that goes with these applications, I'm going to put it in a separate folder. And then I'm going to keep building some packages here. Let's see, actually I better make sure I know what I called it. Sorry, I didn't want to call it Asset Interface. I wanted to call it Account Interface. Okay. Let's right click and refactor rename. And we'll make it Account Interface. That'll just keep it consistent. And then we're going to have these, as I said, these asset and credit account groupings. So I'm going to create right now a separate package for my asset account. So we've got an account interface package and then an asset account group. And I assumed I called it credit account. So the next one will be credit account. New Java package, credit account. Lowercase by default. Now the first thing I'm going to go ahead and declare is the actual interface. So we can begin to understand what it is and how it operates. So if you go to your account interface folder that you just created, let's right-click and ask for a new, and it so happens that there is a Java interface option on our list of new objects. Everyone have it on your list? So let's go ahead and select Java interface. And the interface was just going to be called account. And I'm going to click finish. And you'll notice that it is slightly different in its declaration. Instead of a public class object, it is a public interface object. Now, I'll just put a little note here. By design, interfaces are abstract classes. So we know what abstract classes mean. It's a class that has methods in it that are not developed. There's no implementation code. Well, in an interface, all methods are abstract. So we'll add that note. By design, interfaces are abstract classes where all methods declared are abstract. So it's just going to be exactly that. It's going to be a bunch of declarations. If you want to be an account, here are the things that, by a minimum, you have to have. And so the way to look at this, and the way it's normally explained, is that an interface is a contract. So if the subclass somewhere, or business object somewhere, wants to implement the account interface, what that means is that every method declared in the account interface object here has to be implemented in the class that says I'm going to implement this interface. So the contract is that we declare methods that an account must have, and any subclass or object class that implements account must process these methods, must have implementation code for these methods. So what can we expect? Well, every account will have an account number. So there's going to be a public integer method, and that's just the way I designed the overall system. Public int get account number, so that any class implementing the account interface has to be able to return, has to have a get method for account number, and that makes sense. We also, in this scenario, are going to have a name. If you'll notice on the, go back to the spec for just a moment, when you build an account, you actually have an account name that you're going to enter to go, so you can have the same, checking account. You can have multiple checking accounts, just calling them different things. So we're going to have a public string for get name, which must be satisfied. It has to exist somewhere for an account interface to be complete. The account is going to have to be able to know its type code. So there's a public string get type code, which is going to be the 2-character code, CC for credit card, SV for savings account, et cetera, et cetera. All right. There's also the need for, and we may come back and put some other things in here, you're going to have to be able to get the balance. So there's going to be something called get balance in every case, which is the current balance on the account. So it might be the amount owed on a credit account, or it might be the actual bank balance on a savings account. But there's going to be something we understand as the balance, and we need to be able to get that. we're also going to have process steps. So you're going to have to be able, and this will be a void, to set a charge. And the charge is going to have a double for the amount and a string for the description. Now, a charge on the asset side, on a savings account, of course, reduces the bank balance. A charge on a credit account will increase the amount due, and it'll be charged against the credit limit. But there's still that same process. In every case, we're going to need to be able to set a charge, and by extension, we're going to need to set a payment. Now, payment only needs to receive a double, and so again, this interface is saying, okay, here are the methods that must be written if you're going to be an account. If you're going to implement this account interface, you must write these methods somewhere. But you don't have any code that explains what's really happening. And the variables here, AMT, description, AMT, can be anything. It's really about the type. We're going to have a double and then a string on a charge, and then we're going to have a double value come into the payment. All right. Then we're going to have the interest action. So public void set int action, which is going to be a double that receives a rate. So the interest action on an asset account means that we're earning interest. So we're going to give it a rate and say, hey, pay me a little interest on this savings account or this money market account or what have you. Now, one of the distinctions about an asset that's a checking account is that in our scenario, those will not earn interest. So we're going to have to deal with the problem of, well, some asset accounts earn interest and some don't. Now, the interest action on a credit side is a charge. So a credit card or an equity line is going to have an interest charge accrued based on the rate. But it's still something we can generalize to this notion of an interest action. Okay. Then, of course, we need to get the log. So every type of account is going to have its own 2-digit code plus the account number plus an 2-digit code plus an L for a log file. And every transaction that occurs is going to be logged in or placed in the log. So we're going to have a public array list of strings from a method called getLog. And we don't need to send any parameter to the getLog method. But this is an object, so we're returning an array list of strings, an object that the interface needs to declare, or at least to import, so it knows how to handle array lists. So if you go over to your little red circle that's appeared, you do want to add an import for the Java util array list. So even the interface has imports where appropriate. Well, we're also going to have, and this is a carryover from the Java 1 style of program, we're going to have a public string get error message that can return the error message, and we're going to have a public string get action message. So both of those methods must be implemented by every class that wants to conform to this interface. Well, actually, I'm only missing one, and I think we're going to use it. So let me go back up here. Under the type code, the 2-digit code, there's also a description that goes with that. So let's create a public string function get type description. And so that will be a way for any class implementing this interface to send back a description of what it is. And there you go. There's your interface. Now our job is to write some real objects that implement this interface so we can use our polymorphism tool and have everything just be an account until we need something special. Then we'll have to adjust. Okay? So let me continue a little bit longer with this design setup. Oh, and you know what? Before we do that, though, we downloaded card.java. Let's put that in our package. Even though we're not going to use card.java directly in this version of the program or the application, we are going to be able to pirate some code out of it. So I'm going to go back to my folder here, and I'm going to grab the downloaded card.java, right-click and copy, and then I'm going to go into Accounts, Source. Now that I've got the account interface in my source, I'm just going to drop it right next to my account.java interface. Again, not actually going to be used directly, but it's a code reservoir, as it were. So if we look at that, we've now got account.java and card.java. Because the first thing I want to start building is my asset account, which is going to need to do all of these wonderful things. But are we okay? Are we good to go? So under the asset account folder, we're going to right-click and ask for a new Java class. Okay, so the class here is asset account and so this is going to be the superclass for all of the asset type objects. Couple of things, however. We already know we're going to have, at minimum, on an asset account, a checking account, a savings account, and a money market account. So those are the three subclasses. They're going to, some of the methods, particularly the two-digit code for the type code, those have to be stored in the subclasses, not in this superclass. Now the superclass in this version of the, design can do a lot of the work, but it can't do everything. So it's actually going to be an abstract class. So it's going to be a public abstract class. And here's the interface kicker. Implements account. So what we're saying is that an asset account tree, which may contain any number of subclasses, it's going to be an abstract class because some of the methods aren't written until the subclass, but it's going to implement this interface so that any method declared by the account interface needs to be handled in this scheme. But I think we need an import. So if we click our little red circle, it says, hey, the account interface isn't here, it's over in the account interface folder. Do you want me to import? And we do, of course. All right. Let's see. What objects are we going to have in our asset account variable list, or what items? Well, I think we're going to have a private integer for the account number. The asset account is going to actually do the work of creating the account, and some of the subclasses that we end up with are going to be pretty short. It's almost going to be, well, why do we need them? And we need them just because that's the design. So this is now a design concept for an inheritance model with an interface. You could separate code into different places. You could put some of the code here in the superclass. You could put some of it in the subclasses. In order to eliminate redundancy, I'm going to put most of the code in this asset account superclass. But again, that's a design choice that can be different from programmer to programmer. But if we do have the asset account superclass do most of the work, then it's also presumably going to need a private double for balance. Because an asset has a balance. It doesn't. Now the asset does not have a credit limit, but it has a balance on the actual deposit account. And then we're going to need private strings for our action message, act MSG, and error message. So those will be needed. And I'm also going to have the asset account, and this seems almost counterintuitive, but I have to do it this way because of where the code is going to be. I'm going to have a private string for the name of the account and the type code. Now we said that the type code isn't known until you get to the subclass level. But we're going to have the subclass communicate its type code to the asset class because it's at this level that I want to be able to build new accounts. Okay, so let's try and think about what it's going to take then to instantiate an asset account, knowing that you can't directly, we can't create object A, which is an asset account, but we can create object A, which is a checking account, and the checking account subclass will need to call a constructor in this class to do some of its work. So that constructor will look something like this. Public asset account will need to receive the string for type code, I'll just call it TC here, string for name, and because we're allowing the user to input a starting balance, I don't know if I made that clear, but if they're entering a credit account, we're actually going to change the title on the label, credit limit, but the input, if they're entering, no, I don't have it there, if they're entering an asset, it's going to be the starting balance. Okay, so I'm going to have a double SBAL for starting balance. So when the subclass calls this superclass constructor, those are the values it needs to do its job. And it can then set the global type code equal to TC that comes in. It can set the, well actually, let's set the account number to 0. And this is the constructor that is for new accounts. So I should have mentioned that. So if they're trying to create a new asset account, this is the constructor that's going to be called. Because if they're trying to reopen an existing asset account, then they'll have a different constructor that needs to receive the account number. But in our case, the account number is 0 to start, and we probably ought to set the action message to the empty string and the error message to the empty string. Wow. This is not helping me. And then one more thing. I'm going to set the balance to 0 to start, even though the double starting balance comes in. I'm going to wait to set that until I'm sure I have a live account, a working account. Wouldn't have to, that's just my choice. Okay, now I think we can look at pirating some code, because an asset account that is creating a new account is going to build, or it's going to randomly select an account number and then try to open that type of account with that asset, with that account number, hoping that it fails, that the account number doesn't exist yet. Now if it succeeds, then oops, that was an account number that was already used, so we have to go back and try again. But that is the process that's already in card.java. So if you go to card.java, under the empty constructor, so in our new program, we don't have an empty constructor, but we do have the same process. We've got under card no parameters a while loop that looks to continue its work as long as the account number stays 0. And so I think we can take all of that method, and we've also got this problem of writing a status file and a log file. We're going to copy some code there too, but for right now I'm going to grab the entire while loop that is inside the empty constructor of card, do a Control-C, bring it over to asset account, and see if we can Control-V it, paste it in, see if we can't adapt it to work for any type of asset account. Okay, so there are some changes that will have to be made. So we're going to look through this line by line on this code. Now the first step is that if the account number is 0, we're going to use a random function out of the math class, just multiply it by a large number so we get an account number that's got some significant digits to it. Turn it into an integer. Could even turn it into a long, but this will work. And try that account number. Then we're going to have a buffered reader, but here's one change right away. The file reader needs to be based on not CC, because card.java only knew about credit cards. It needs to be based on the type code. So this type code that we just set, plus the account number, plus .txt. And this is where we're hoping that we throw an exception, because if we don't, if we just fall through to the close, then that account was already in place and we've got to try again. But this is where the 2-character code comes in. Now if we catch an exception, which is a good result, the account does not exist, there's no credit limit concept on the asset account side. So we can simply remove that line altogether. It doesn't need to be there. We're still going to have a write status. We're still going to have an action message or an error message, and we're still going to have a log. So the rest of this code is okay, but down here at the end, if the error message, if we tried to do a status update and a log update and we couldn't do it, then we're going to set the account number to a fatal error code, and that's a -1. But again, where you see this .c limit equals 0, we don't need that line at all because that's not a part of an asset account. Okay. But if we're successful, we do have, whoops, I guess I shouldn't have deleted that line entirely. I'm really rewriting it. Let's put a blank line back there. We do have two actions in the case of a successful write of the status in the log. So if we're in the catch, the IO exception to begin with, but we get down here and the error message was never filled, then we have an account. So this name will be equal to the NM that comes in, string NM. So that's the name of the account. And this balance will now be set to the SBAL, that's that parameter that comes in. Oh, I can't quite show it on one screen, can I? Too bad. So we've got the name coming along with the code and the starting balance on an asset account. And so if we've decided everything looks good, oops, I'm sorry. Oh dear, maybe I should give up tonight. I'm coding in the wrong spot. This little block of if code is if the error message is not empty. I was thinking if it is empty. Okay, so that's not any good. Let's see. We're going to take these two lines of code and put them somewhere else. Let me see if I can manage my yeah. Let's just put them right under the catch. So I'm going to highlight those two lines, do a Control X, bring them up right before the write status. Okay. Now I like the code a little better. So if we hit an exception, then we think we've got the account set, named and balance set. But if we end up, after we try to write the log files and the status files, if we end up with a non-empty error message, let's just set the balance back to 0. I'll leave the name in place in case we wanted to inquire about it for some reason. Let's also modify our action message just a bit. I'm going to add the type code. So this dot type code plus account. So it'll say something like SV account, or checking CK account 123 opened, or SV account 123 opened, and that kind of thing. All right. In fact, we could say SV account, let's include the name as well. Oh, I've got too many pluses. There we go. Okay, so now we'll include the name. So our action message that's actually going into the log will show the name inside the log as well. So it'll be SV account 123 savings, account number 567 opened. Okay. And that should take care of the empty constructor, which is not really empty in this, but the constructor where we're doing a new. So the constructor for the new account. That should be all we need. But we want a write status and a write log process, and I think we can pirate those from card.java. So let's go back, card.java, and search for write status and write log. Happily, they're together. We are going to have to modify because they are assuming a CC as our type code. But go ahead. Did everybody find the status and log in card.java? So I'm going to click and drag from the beginning of write status all the way through the end of write log. Control C to copy, and then back to asset account. And I'm going to paste. Ooh, I've got so many closing curly braces. Let's see where all these are. Okay, so this is the end of the while. This is end of the constructor. So after the constructor and before the end of the class, I'll paste in write status and write log. Control V. That'll prompt some imports, which we'll let happen. And then we will update for an asset object the values that are actually written. So on a write status, we're still going to have the file writer, but remember that it's not CC, it's this type code plus the account number plus TXT. And we're going to put the name, I'm going to put the name at the top of the status file. So my first out.println will be this.nm, and it'll be the balance that goes second. So this.balance, it's not really a balance due, we're just calling it a balance. And then you can close. And if you want to, you can improve your error messages if they fail. So error writing status file for type code, account. Oops, forgot a plus sign there. Okay. And general error in status update, I'll just leave that the way it is. This is one of those programs where you have to do lots of coding before you can actually do any testing. And in fact, we ought to do a save all while we're thinking about it. Okay, so that writes a status file and an account, or rather an asset type object. Status file will be just the name of the item and the current balance. Name of the account and the current balance. A log. So the log will still use the L idea, but again, no CC at the beginning, so it'll be this dot typecode plus L plus the account number. And don't forget that true setting on the file writer causes it to append, but the timestamp is still the same. And the message that comes into the log writer is still the same. Is still handled the same way. I guess my error message here was a little less cryptic or less informative. I think I'll modify that. Error writing log file for type code account number plus action message. Just to make it a little more meaningful if it does happen to throw an exception. Okay, well, if you go back up to your public abstract class, implements account, I guess actually it's not throwing an error because we made it an abstract class. But we do have to decide what methods of the account interface can be satisfied by this class. What can the superclass do? So we might need to refresh our memory on what the asset or account interface has as its requirements. In fact, why don't I, it might be easier, I don't know how you feel about it, I have it in front of me. Why don't I print out the account.java interface? Does anybody want it, need it, have it in front of you? You're okay? You can go back and forth? I always have trouble. That's all right. I guess we won't need it then if no one wants it. Okay, asset account. Methods that we can satisfy would include the get type code and the get name, because those are carried here. So we can do public string, let's do int first. Public int get account no, that was a method that the interface requires. And we will return this dot account number because it is carried at this level. After you type that, you'll notice that it says, hey, that should be an override annotation because we're implementing account, and account is the object that specified this method. And so an interface is kind of like another superclass. As we said, in C you could actually have two different superclasses. You could extend two classes. Interface works the same way. So let's go ahead and let it click your little warning there and let it add the override annotation. And then we'll have public string get name, and that will return this dot nm. And that's also a method of the interface. So we'll let it set an override there. We know about the balance in this class, and we know about the error messages and the action messages. So we're going to implement those. So we're going to have a public double get balance, is what we called it. And that will return this dot balance. And that's a method that's overridden. Error message, so public string get error message will return this dot error message. Override. Public string get action message. Return this action message with the override. All right, well, I think we can grab some more code from card.java. But it's going to require us to make some changes again. So let's see. Card.java has a set charge method, although this was a set charge for a credit. So there'll probably be a lot of changes. Well, I'm going to go ahead and use it as a basic structure. So let's click and drag from card.java public void set charge. And you know what? Set payment is right below it. So let's go ahead and do that. And get log is right below that. We still want to do that. So I'm going to set interest charge. I changed my mind. I'm not going to copy all that. Let's do it one at a time. I'm just going to do set charge. That was too much code to think about. Okay, set charge. Control C into asset account. Paste it in. Okay, public void set charge that receives an amount and a description is an override, so you can let it right away add the override annotation. But we've got some changes. Okay, so in this case, if the account number isn't active, then charge attempted on non-active account, we just set the error message and return. If amount is less than 0, we're only going to accept positive values. So charge of, I don't have my C, my currency formatter. Apparently I just called it C here. Let's add, it expects it to be a global evidently, so let's go ahead and put it up top. So we'll do a number format C equals number format dot get currency instance, and that requires an import. Uh-oh, I misspelled it. Huh. Capital F, number format. Now it should require it. Oh, it did the import, or it already had an import. Okay, already did it. Number format C, get currency instance. So that if in our set charge we have a negative amount, negative or 0 amount, charge of C.format amount for description is declined, and I'll change this, amount not positive. But I am going to write that to the log. Now the only thing I can change this next else if, because this was for credit accounts with a credit limit, so all we have to check on the next if is the amount greater than the balance on the account. So if amount is greater than balance, then we have to say charge of that amount for that item declined, and it's not over limit, it's insufficient funds. And then we write the log. Otherwise, we can do an adjustment. So we can do a minus equal amount, because the amount that came in is a charge against the assets balance, the account balance. So we take balance minus the amount, and then we write the status. And if the charge didn't go through on that point, I'm not going to worry about a message. I'm shortcutting a little bit. We adjust the amount, write the status, and assuming it's empty, well, I guess we shouldn't. Assuming it's empty, the error message is empty, we write the log. Otherwise, I guess we should say that if we fail to write the status file, then something serious has happened. So we probably need to back out the operation. So we'll add amount back into balance, and we'll set. Actually, that's all we need to do. It's already got the error message in place. Something happened. So we just put the amount back in. All right. Set charge is in place. We haven't even gotten to the form at all, have we? Oh my. Ability to set a payment. Card.java. Set payment. This one's a little easier. And I think I will grab the get log, because that should be pretty straightforward. So I'm going to do the payment and the get log together. We'll come back and think about the interest charge in a minute. So Control-C into asset account for those two items. All right, set payment. First of all, override annotation. Check for a non-active account. Check for an illegal message. I'll change that from illegal to amount must be positive. And then a payment concept, for, from an asset standpoint, a payment is an addition to the balance. So if we're making a payment into the account, we're depositing. So payment is really a deposit. So I'm going to add the amount into balance, write the status, and if it's empty, then the action message is, rather than payment, I'll go ahead and say deposit of posted. But if we fail to update that status file, then I guess we better take that amount out. That deposit was declined or returned or couldn't be processed for some reason. So we'll subtract out the amount just to make sure our balance doesn't get out of whack. Okay. Lots of code before we can get even a test. Let's look at get log. Oh, I did the override, right? Yeah. Set payment is overridden. Get log override. I don't need redundant type arguments. So this was an older version of a program. So when you declare your array list of strings, which will be the log that you're building, new array list doesn't need string on the right-hand side, but that also makes me wonder what JDK level. I didn't check that when I opened the account, so I'm going to go up to my accounts project, right-click, ask for properties. JDK 7, let's go to 8. 7's not too bad, but 8 is better. All right, so let's see what we have to change here in the get log. Same kind of issue if the account is not active. There's no log. We should say log request on non-active account. Makes me wonder what I had up here. Charge tab, deposit attempt on non-active account. Okay. So log request on non-active account, or we're going to create our reader, but remember it's not CCL that we're reading, it's the file that starts with the type code of the asset object plus the L plus the account number. Then we're going to read lines in, put them all inside our H ArrayList object, and history returned or error message reading log file, and we return H. I'm not going to worry about those messages too much. I think we'll always get them, always get the log. Okay, so the only thing we really had to change, other than a couple of wordings here and there, was the type code again is used to access the correct log file. I just changed the account number, and then, well, anytime I looked for a non-active account, I just changed the message to match the operation. So, sorry, a payment operation is a deposit on an asset account. So I just changed that word. Well, we've got a lot of it taken care of. In fact, almost all of it, except for the interest action. So this is the last item to satisfy our interface requirement. So if we go back to card.java and set interest charge. Now, it's not really a charge, and it's also called an interest action now. So let's see. Do I want to copy this code or just duplicate it? Well, let's see. Yeah, I'm gonna copy only the guts of it. Set interest charge, not the public declaration. So Control C for the guts, but then under asset account, because of the interface now, we're going to change the name. So this is the end of get log. So we will have a public hold on, got to get to the right spot in my notes. A public void set int action is what I ended up calling it in the interface. Int action receives a double for the rate. And then I can Control V in the guts of my action and see what needs to be changed. Oh, interest action is an override again. Okay. Interest attempt on non-active account. Oh, I called it IR. I'll change my. So in the process, I called it IR instead of rate. So I'll change my parameter to IR. And that'll clear up a couple of things. So interest rate of P. I don't have a percent formatter, so I guess I better build one. I'll do that locally. Number format P equals number format get percent instance. Changed my messages to not positive again. But if the rate looks okay, I'm just going to take anything they give us that's not a. Actually, let's do this. If the interest rate is less than or equal to 0, or IR is greater than 1, I want them to enter the rate as a decimal, you know, like 0.06 for 6%. Then we'll say interest rate declined, rate not positive, or too large. Otherwise, our interest charge is the balance times the interest rate divided by 12. So you do adjust the rate. They're going to enter an annual rate. We adjust it to a monthly rate. We apply it to the balance. That's the charge. And then you can do this. We can set the charge. We can call the set charge using the interest charge we just calculated, and it's not interest charged on an asset account, it's interest earned. And the write status and write log methods will be performed in the set charge method. End of interest action. Actually, this is the end of the interest act. End of set int action. Wow, that was a whole lot of coding. And we're not even close to being able to test, but we do have the asset account in pretty good shape. So I think it's time for a break so I can get a drink and I hope stop coughing into the microphone. Don't forget to do a save all. That's about all we can do at this point, but we'll pick it up here in just a while. Where'd my, oh, there it is. Paused recording. Zoom recording. So the question becomes, what is actually left as an abstract method in our asset account? I said when we started off that it was going to be an abstract class, but we seem to have implemented all of the methods but one. There is a description that goes with the type code, and that is going to be carried just in the subclass. So, at the very, very bottom of asset account, the one abstract method, which therefore makes it an abstract class, is, and it's a part of the interface. So it's defined in the interface, but it's not been implemented. Here, it is public abstract string get type description. And that needs an override annotation, but it's an abstract method, so it's not implemented in this class. We should, however, be able to now write one of the asset classes at least. Well, checking and savings are the two main asset classes. We'll come back to money market in the future. But let's go ahead in the asset account package. Let's create a checking.java, which is what the spec asks for on a checking account. So new Java class. Oh, you know what? Wait a minute. I think I'm going to do savings first. Let's do this. Let's do the savings account first. Sorry if you were typing ahead. Savings.java. Okay. So public class savings is the subclass for asset account. So it extends asset account. It has as constants the type code and the description. So public, static, final string, type code equals SV, that's the savings. Public, static, final string, type description equals, we'll just go with passbook savings, the old style term for a savings account. In which I was young, actually earned interest. These days, it earns essentially zero. Okay, so this is a polymorphic approach, meaning that asset account itself, even though it implements the interface, cannot be instantiated. You have to instantiate from the subclass. So we need a public savings method, and the user or the form is going to send us the name. So we're going to have string NM and double start val or sval. So those we know will come from the form. What doesn't it like about that? Okay. All right. But here, we know that when we instantiate the superclass, we're going to call the constructor. So we're going to do a super dot, parentheses. Let's try that again. Let's try super, parentheses. What needs to go there? Well, the name goes first. So NM. Wait a minute. Does the name go first? How did I do that? Constructor says type code goes first, I think. There. Yeah. Type code, then name, then balance. So here's our problem. How do we send it the type code? And the answer is you just send it the constant that's in the class. So we can actually send savings.typecode as our first parameter, and then NM, and then starting balance. And the super, remember that when you call the constructor for the superclass, if you're going to, it has to be the very first thing you do, and you have to supply all of the values, parameter values, and it just so happens that we've got it as a constant in the string, so we can, or in the class, so we can do savings.typecode to be our typecode constant. All right, that should actually take care of the constructor. We want the get type description. Notice that it's still in red here. Get type description. Savings is not abstract and does not override the get type description. So in order for the superclass to know its description, we have to have public string get type description, which returns, and all it returns is savings dot type description. But that is an override. Oh, I thought I did get type code. Okay, hold on. It still doesn't like one of my, it says I should be getting the type code as well, but if in the asset account, Oh, I didn't actually, did I? I didn't do a get type code method. I was thinking about it. Again, this is a design decision. I'm going to go ahead and leave it as an abstract. Let's go back down to the bottom of asset account where we had abstract for get type description. I'm going to do that as well. Public abstract string get type code. And we'll do an override on that one. Yeah, I mean, we actually have the type code in the asset account class, so you could just write the method here, but I like pushing it back down to the sub-account or subclass. So let's do that. And so on savings.java, we'll also then have public string get type code, and we'll return savings dot type code, and that will be an override. And I think we can now talk about doing some coding on the form side, because we should be able to instantiate a savings or SV type account if we can get the form doing its job. Oh, but it's okay now? Yeah. Sometimes it takes a second for it to figure out. Okay. Let's write some form code. Uh-oh. Oh. My system wasn't responding. I was afraid it hung up there. Interesting. The gaps. Huh. Okay. All right. So I need an event should they decide to create a savings account. And so on the file, create asset account savings. I'm going to go that far. So that's JMNUSV. Once you've got it selected, we're going to right click and do event action action performed, which of course is the click for a menu, the default action. So we're going to start writing some code, assuming they choose to create a savings asset account. Now, one of the issues we've got is that the top line of that form, I shouldn't have come back here so quickly to the code. If we look at the spec, top line of the form, getting real strange behavior on my system, needs to be filled out in part for a savings account, and that includes whether or not the balance field is going to be available or not in these buttons. So, in order to set the action to what it should be, I'm going to do several things. I'm going to do a JTXT type code. That's my type code, that first field. I'm going to do a set text to, and we know what it should be. It should be the savings dot typecode field. And then the account name, which is JTXT account name, nope, account NM, gets cleared. So we do a set text empty string. Again, we're setting the top line. JLBL start val, that's the label on the next field. So the label needs to say, with a set text, initial deposit with the colon. And then the JTXT start val, that field itself needs to be cleared. That text field will be enabled. So JTXT start val set enabled to true. So it's going to be available on a savings result. And then we're going to put the focus in the window. So JTXT account name request focus in window. So they're not going to be putting in the type code. That the system knows what that is. And so we're going to jump straight to the name field for the placement of the cursor. However, when we run the program, we haven't really launched it at all, so let's go ahead and bring the form up. Right, I'm running the last class program. Okay. Let's try again. How about if I set accounts as my main project? I think I do that every class, just about. I run something and it's the wrong program. Wow. Come on, form. You can do it. Wow, it's taking its time. Okay. But when you look at that form that has something, I can type in the type code. I don't want to be able to do that. That should be not enabled. Anyway, what I was going to say is that this whole top line really shouldn't be there when the program launches. And it should only appear when I ask to create an account. So it should look like that. So how am I going to accomplish that? Well, let's do a neat little bit of coding here. I don't know if I did this in the cute way or if I just did straightforward way. Let's see. My fingers don't seem to be working tonight either. I can't turn my page on my notes. Oh, I just did it the simple way. Okay, well that's all right. Let's go down below and write a little method. So we're going to write a private void to set the input line, visible or invisible. So I'm after my save action, but I'm before my globals that are below. So we're going to have private void set input line, and it takes a Boolean. I'll just call it TF for true false. And every element on that line will be set visible based on the Boolean that comes into this method. So those items are JLBL type code set visible TF. So that's the first label. And then we know JTXT type code itself, the text field, set visible to TF. JLBL for the account name, set visible. JTXT account name, visible or not. JLBL, the label for the start val, set visible. JTXT for the start val. And then my buttons. So JBTN create, it should be one of the buttons. Yep. JBTN create, set visible to TF. JBTN cancel, set visible, that's the other button, to TF. Okay. So I now have a method which can turn the line, the top line, on or off. So okay, that's interesting. I don't want to do that. I don't know what device they're talking about either. The computer itself? Strange. All right. So under the save action, create a savings account, the first thing I want to do is I want to set input line to true. I want it to be visible. So that should do the job as far as the input line goes, except I've got the problem of what do I do when the program launches? And the answer to that is I have to go up under the constructor area of the form. Is everybody okay on this? Okay, I'll wait a moment. Okay. So back up under the constructor for the form, after the init components has run, then the elements on the form should be accessible to code. So we should be able to do set input line false and not have the program blow up. I also want to take care of one item on the design side of the form. I want this field, JTXT type code, not to be editable. So I'm going to remove the editable property, because that's filled by the program. All right. Let's run the program now and see if our form behaves more like we want it to. That looks good. Top line is missing. File, create, savings, SV, account name, initial deposit, and then our operation, we can either go through with the create or we can cancel. Okay, I think we're ready to do a little more coding. So now I'm going to write a method for the actual create button. If they go through that far, so I'm going to right click, events, action, action performed. We should probably, well, I'll go ahead and write it. We've got some code. We got to make sure that our values look okay. So double SV starting value, and I'm going to do a couple of if checks. Oh, let's do status message label, set text to the empty string. Let's make sure our account name isn't empty. So if JTXT account NM get text is empty. They forgot to put something in there, so we'll give them a little status message label, status message, set text, missing account name, and we can return the focus to there. So JTXT account name, request focus in window, and I think we can just exit out at that point and say, hey, you got work to do. Give me an account. On the other hand, we need to make sure that the value that they gave us is, for the starting value, whatever that type of account may be, is valid. So we're going to, inside a try catch, try to set SV equal to a double, parse double of JTXT start val get text. And if we catch a number format exception E, that's really the only kind of exception that can occur with that line of code, then we need to let them know. Now we have a choice. We can either just plug the value to 0 or make them enter something. I think if it fails to convert to a double, we ought to make them do it over. So status message, label, set text, illegal, missing start value. JTXT start val, request focus in window, and return. Now here's the fun part. We want to instantiate an object which will be an account. But do we want to instantiate in the asset account tree or in what will be the credit account tree? And the answer is, well, neither really, because here's what we're going to do. We're going to go all the way up and declare a global of account A. Now this is a little unusual. We do need an import for account interface.account. We're actually declaring an object which is the interface type. You don't normally do this, but it worked out well enough in this scenario. So we're going to have an account A interface, but we will be able to back down in our create action, we will be able to instantiate based on the subclass. So what are we we're going to end up with several to do here. So I'm going to do it in the switch. And in the switch, and this is kind of fun, we are actually going to switch based on the JTXT type code dot get text. So we're going to pull the type code out of that top box. And I'm just showing you that in Java 8, 7, and 8 you can do this. You can switch on a string. And we're going to set a case, and the case is if it matches savings.typecode. We're going to do something. And what we're going to do is we're going to set A, the global asset, or global account, excuse me, as a new savings object, and we need to send it the account name, JTXT account name.getText, and then the value, SV. Don't forget your break. But so if you look at savings.java, just to remind ourselves, that expects the name and the starting balance because it knows it's an SV type. And then it's going to call the asset account superclass with the proper type code, the name, and the balance. So back on the form, name, balance, and then we're going to have a default, and the default right now is status message label, set text, unknown or not implemented type. All right, so there is our what will end up being a full structure for all of the types, but the trick here is that we're actually declaring an instance of the interface, instantiating it with a subclass which extends a superclass that implements the interface. So it's kind of a roundabout way of doing things. But it works. Let's see. We're going to have a couple of more blocks of code before we can do a final test here, or an initial test, not a final. After we run through the switch, we probably ought to, in our default, we ought to set A equal to null. So that's our asset object, setting it equal to null. Or I keep saying asset, our account object. Okay, so if A is null, or A.get, excuse me, let's do it the alternate way. If A is not null, and A dot error message, get error message, is empty. So if A isn't null and the error message is empty, then we had a success, and I'm going to create a display values method which fills the top part of the screen, and I'm going to do a status message label set text, which is the A dot, and there they all are. All the methods get action message, so I'll display the action message. Otherwise, else, if A is not null, so we had something but there was an error message, then we'll do a status message label set text of A dot get error message. Otherwise, we're going to have to supply our own error message, status message label set text account open failed. No specified reason. Well, that's not really. Let's just say account action failed. Okay. So if we think about what's going on this is all happening on a create. So if we get all the way through to the end, our switch is finished, we've checked our status, we've either displayed the values or we've displayed an error message, we know that the input line should go off. Whatever has happened, the attempt has finished, so we need to do a set input line false, so they can't accidentally try to recreate the same entry. And we probably ought to do put our cursor somewhere. I'm going to put it in the charge. Oop, I didn't call it charge. JTXT. What did I call it? CHGAMT. Okay, so JTXT CHGAMT request focus in window. Just going to put the cursor somewhere. I think we'll be able to test one time before we're done with our evening. All right, so what will display values need to do? So I'm going to come down here below input line, public void display values. And remember, we have an A object. If we get to display values, we have an account object. I'm going to create a number format. C equals number format get currency instance. And now it's just about filling the top part of that form. If we bring up the top part of that form with the appropriate information. Okay. So we know we have an account name, so we can do JTXT account. What did I call it? I've got account NM on the input. What did I call it here? Oh, display name. Sorry, JTXT display name. So display name does a set text with a dot get name, because that's consistent for all. And then the account number, JTXT account number, set text with a dot oh, this is a numeric if we get the account number. So we're going to have to string dot value of a dot get account number. So that'll put the account number in the proper field. I put the type description in that type field. So JTXT type is what it, nope, it's not what I called. It is called account type, JTXT account ACCT type. Okay, so JTXT ACCT type, come on. Oh, still not. What it, come on. JTXT, oh, account type description. I am never that wordy. Oh well, account type description, there we go. Set text, and this will be a dot get type description. And then the balance. We know that the balance is always the balance. So JTXT balance set text to the C dot format of a dot get balance. Okay. So right now, I think that's all I need in my display values. It's going to get a little bit more complicated as we start adding other classes to it. But let's see if we can get a clean build and if this will solve our problem, or at least run. Okay, so my errors are gone. I want to try and create a savings account. So nothing there. Do File, Create, Savings, SV, Savings at Bank of America. Initial deposit, $1,500. Okay. Create. Well, something happened. It says this SV account savings at Bank of America 434827 opened. Savings at BOA is account name, passbook savings account, account number, balance. Now, available credit limit equity value don't have any meaning for this type of object. So that's something we'll have to deal with. But I think I have an open. Let's see if it in fact showed up in my project area. So I'm going to do a File, Exit. Go out to my project area. Under Build, no, under, yeah, it should be under, oh, there it is. No, it's right under the, it's not under Build. I'm thinking of the web apps. Here it is, right here, right under the accounts. Let's see what's inside my SV, savings at BOA. There you go, the amount. The log file says SV account savings at BOA with the account number opened at 9/16. So I think I've got files. Now I can also, in fact, while I think about it, no, I can't. I don't have code for it on the form side. I was going to say I could try an action like a charge or a payment, but that's not going to work until next time. How'd we do out there? Whole lot of coding with only one little test at the end. Success? Okay, some problems? Okay, so we still have some time to fix some problems. What I would like you to do for this week, we're going to come back and we're going to look at the checking account and the fact that checking is slightly different from savings in that there's no interest action allowed on a checking account. So how are we going to implement that? So that I will address at the beginning of class next week. what I want you to do, really want you to do, because I probably won't ever do it for you, is see if you can start the credit account process. So we're going to create another. We might as well do it right here if I have what I wanted to call it. Asset account. I don't have it here. Oh yeah, here it is. I did just call it credit account. So let's quickly right-click, New, Java class. The class is credit account. So this is the other tree, the other side of the house, if you will. See if you can finish public abstract class credit account which implements the interface account. So there's your starting point. Now I have an error in my system which will prevent me from running. So you actually might want to comment this out until if you're trying to get if you didn't get your other program, I mean the first part of the program to work, we might need to fix this. But anyway, this is where I want you to work. See if you can get a creditaccount.java built this week that mirrors asset account, but of course is a credit handler instead of a bank balance, the bank account handler. Okay, and we will call it a night on our end for this. Don't forget to save all. Get all that red in place. And also, as we talked about in class here, but I don't think I put it on the recording, the PV part of financials will be due in a week. So that little midterm exercise will be due by 10 p.m. next week. All right.